And welcome once again, everybody, to the Daily Space Weather. Congratulations on knowing that these videos exist. Today we'll be talking about superionized water, climate versus the Earth's rotation, condensed matter. What about Sunspot 2808? Here it is rising in the northeastern limb. It's an alpha class sunspot. Likelihood of major solar flares isn't really particularly high. We did see a C-class solar flare yesterday, and we'll be showing you momentarily. So here we're looking at a full disk view. Once again, this is 304 angstroms, ionized helium, and that C-class flare does appear to have come out of Sunspot 2808, which is this area right up here. We've got a couple more full disk views here for you. Here is 171 angstroms. And we've also included 193 angstroms today to show you this large upside-down question mark-shaped coronal hole associated with the south polar region. We do see a slight uptick in the likelihood of coronal mass ejections, although not on the Earth side of the Sun. No worries there. Very low likelihood of Earth-facing coronal mass ejections happening in the near future. Here's where stuff is in the solar system, and we like to orient our viewers. Here's where stuff is now, and there's where stuff will be in a week. Here's a star chart. If you're wondering what's overhead, check out in-the-sky.org. We're not paid to say it, but I like to use it. I draw in the ecliptic, which is this yellow line you see here. And if you're up before dawn, you may see Saturn rising ahead of the sun still. The question I pose to you is, where will you be when Deneb sets? The 10.7 centimeter radio flux is now at 84 solar flux units. So an additional uptick there as we saw that large alpha class sunspot rotate in the northeast. And if you're wondering what the radio flux is, it's the radio output of the outer chromosphere and lower corona. Here it is plotted on a graph on solon.info along with the sunspot number. So sunspot number here is the red line, radio flux is the black line, and you can see how proportional those indeed are. This needs updating as it's actually up here at 84. And there's the radio flux and the sunspot number on a different type of graph. You can find that yourself if you look up the Space Weather Enthusiast dashboard. We see another volcanic uptick here. Just before earthquakes, we'll do volcanoes. So here is the Volcanic Report. Etna, another paroxysm happened at Etna late last night. Strombolian explosions merging into lava fountains as the activity continues at Etna. Now, regarding Iceland, Fagradalsfjall may be set to erupt, but really what they've done here is they've done an earthquake forecast. So we'll have to keep an eye on this. And this time when I say eye on, there's no pun intentional at all. The number of earthquakes around Fagradalsfjall has surpassed the 20,000 mark. And they're forecasting the possibility of up to a 6.5 magnitude earthquake there. And even a location approximately 20 kilometers east from the main area of unrest. Mount Abico is also erupting, 7,000-foot ash plume above it on Paramushir Island. Sakurajima exploding. flight level 080 there. It's an 8,000-foot ash plume. And here's one I've never heard of, Bagana. Now on the list, it's exploding on Papua New Guinea. So Bagana, it's producing an 8,000-foot plume of volcanic ash. Sinabung, 11,000-foot plume of ash above it on Indonesia as it explodes. Dakono on Halmahera, exploding as well. Flight level 080, 8,000-foot ash plume. Veniaminoff on the Alaskan Peninsula, 12,000-foot ash plume as it explodes. Popocatépetl exploding, 19,000-foot ash plume. San Cristobal now on the list on Nicaragua, 8,000-foot ash plume there. Sangay on Ecuador exploding, 23,000-foot ash plume. Revenador exploding, 16,000-foot ash plume. Those are both Ecuadorian volcanoes. And Sabancaya once again producing a 26,000-foot ash plume, reminding us not to pole vault the caldera. We see some earthquakes in some weird spots, such as this one in Gabon over the past 24. Let's just scroll up the list here. As the aftershocks continue in the Kermadec Trench, north of New Zealand, following that 8.1 magnitude quake that generated tsunamis. Here's a deep one in Vanuatu. And we've got information about the composition of the Earth, folks. Some very interesting cosmology and indeed climatology information will be expressed in this video. So here's a deep quake at Peru and a deep quake at Fiji. So we saw 3 deep quakes here happen, all within a few minutes of each other. This one at 1914, this one at 1916, and this 600-kilometer deep quake at 4.6 magnitude near Fiji at 1935. So only a few minutes separating 3 deep quakes at different spots of the world: Vanuatu, then central Peru, and then Fiji. Also a deep quake at Wallis and Futuna. A deep quake at Afghanistan at over 200 kilometers. So an interesting deep quake event there. Also, we see another 5.1 magnitude quake there at Iceland. A deep quake near Japan. South of the main island there, a 4.3 magnitude at over 450 kilometers depth. So some interesting seismic activity there. Let's go back to some space data. Here's the GOES X-ray flux over the past 3 days, and we saw this C-class flare kick off. And that peak flux happened there at 12:30 Universal Time, just after noon Greenwich Mean Time. And I've completely failed to show the maps. What the heck is up with that? Anyway, there's the list of earthquakes. Sorry about that, folks. We are streaming live. And these things do happen sometimes. So anyway, there's the GOES X-ray flux. Over the past 3 days, you can see that C-class flare there. Proton flux doesn't show any spikes over the past 3 days. No surprise there. We would have let you know if there was a coronal mass ejection. And here's the GOES magnetometer data over the past 3 days. We see an arc jet moment there. That's just the GOES 16 maneuvering, as the plasma created by its thrusters can affect its magnetometer readings. Next, looking at the current sheet, the heliospheric current sheet. The Earth is solidly in the South Pole one. And no real surprises there. Here's a line of sight coronal hole plot, and you can see that question mark shaped, that upside down question mark shaped coronal hole there associated with the South Pole. As the solar polar field reversal seems to really be taking its time as cycle 25 progresses. Next, we'll move on to the real-time solar wind. And let me just check the life of the stream here and make sure that I'm showing the correct stuff. All right, everything looks just fine here at the Smash News Network. Least busted name in news. So solar wind density and speed have been pretty steady here over the past 24 hours. No major changes in things like the phi angle or the BTBZ, which are these two top panes. Current solar wind density, only about 4 protons per cubic centimeter. Current solar wind speed under 400 kilometers per second. Right around 400 kilometers per second. We'll say 394 kilometers per second for the current solar wind velocity. KP index has been pegged at 0 for the past 12 hours there. And we will show you some cosmic ray monitors later in the video. The KP index is a measurement of global geomagnetism. Speaking of geomagnetism, here's a visualization of the magnetosphere. It's a geospace magnetosphere movie, and it shows you 4 hours of data. We show it daily on the Daily Space Weather videos, as we cannot access the archival data yet. It's University of Michigan Geospace Model V1.2, based on the Space Weather Modeling Framework, and you can read all about that on the Details tab at the bottom of this page. The Geospace Magnetosphere movies. Here's the other Geospace Magnetosphere movie page. This is the Geospace Delta B, ground magnetic perturbations. And we show this daily as well, 4 hours of data, since we are living through a polar excursion, a geomagnetic polar excursion, where the South Pole has left the Antarctic continent entirely and is someplace south of Australia. And we've got 2 North Poles, one over Canada and one over Siberia. Again, this was streamed live to Twitch. It's twitch.tv/smashamash. Thanks to our followers over there. And make sure, if you're following any place besides YouTube, to view the videos on YouTube. We've got much more exclusive content, as well as playlists to organize the content on YouTube. YouTube.com/smashamash is the main site for our videos. So don't forget to press like and subscribe there. Share with your friends and foes on social media. Share with your science noobs and your science pros. And we're also on BitChute. There's exclusive content there as well. Also, check out our own website, smashamash.com. You can find our social media links, as well as links to donate, thanks to our one-time donors, as well as our patrons, most importantly. You can also find our smAsho forum and our stores there. So welcome to the Neo Renaissance, everybody, and thanks for tuning in. Let's do a cosmology segment. As cosmology is one of the most interesting laboratories that there is. What's going on in space? Well, we've got some interesting stories to cover here at the Smash News Network. We're not going to pick a random object today at all. We're going to talk briefly about radio jets. So Cygnus A, this is from Britannica.com, by the way, the Encyclopedia Britannica. And what you're looking at here is a galaxy about 530 million light years away, known as 3C405, or Cygnus A. Why is it called Cygnus A? Because it is the second strongest radio source in the entire sky. Second only to, wait for it, the sun. Yes. So you see these giant radio lobes here. These are quite lengthy, as the galactic core is way over here. And you've got these radio lobes that are at distances of tens of thousands of light years around this galaxy. So Cygnus A is interesting enough that we put it on a t-shirt. You can find links to that at smashamash.com. It's the smAsho store. You can find also clothing that features the concept of condensed matter and so on. But in any case, Cygnus A, a powerful radio galaxy, and it emits these jets. And these jets come out of the poloidal fields of the galactic core. And without going further into that, let's transition into this article. And this is a phys.org article. And what you're looking at here in the lower right is a 3 different wavelength image. You're looking at infrared light, optical light, and X-rays. And what you're looking at here, this is an artist's rendition here on the left. And turns out that this galactic jet is about 50% longer than the entire diameter of the Milky Way galaxy. So the Milky Way galaxy is like 100,000 light years in diameter, and this jet is about 150,000 light years in length. It is an X-ray jet. Perhaps you'd like to read this article. It's on phys.org in the Astronomy and Space section. A gigantic jet spied from the massive radio source. And yesterday we talked about a massive radio source at the core of a galaxy that's estimated to be 300 million solar masses. This one is estimated to be about 3 times that, about 1 billion solar masses. And this particular galaxy is about 12.7 billion light years away from Earth. And without getting into arguments about things like redshift calculation and so on, the magnetic fields and the torus around these objects seem to have some sort of a relationship. And I don't want to get too in-depth into it because this is indeed in the cosmology segment. It's PJ 352-15. So again, that X-ray jet over 150,000 light years in length. The Milky Way is only about 100,000 light years. So that jet, about 50% longer than the Milky Way galaxy, is wide. So perhaps have a read about that if you like. Again, that's galaxy PJ 352-15, another massive radio galaxy with extremely lengthy poloidal jets that come out of the poloidal fields of the galactic cores. And let's continue with cosmology here to talk about condensed matter. Now, you may or may not know about the liquid metallic hydrogen theory of the sun. It's kind of important in that the sun appears to not be made of a diffuse gaseous plasma. And the originator of this theory is this gentleman here, Pierre-Marie Robitaille. And I'm going to play you a small clip from the video. This one is entitled, "The Sun is Not a Gaseous Plasma, the Liquid Metallic Hydrogen Solar Model." And by the way, liquid metallic hydrogen is what we call a single segment plasma, in that the nucleons are constrained into a lattice structure. As you see up here, the nucleons are constrained to this lattice structure. However, the electrons are free to flow around, and it behaves like a metal. So it's a liquid metal, and we have created liquid metallic hydrogen on Earth. More about superionized materials in a moment.
Objects simply do not radiate internally, but use conduction and convection to achieve this end.
He's talking about the radiative or alleged radiative layer inside the sun. And when you have objects right against each other, you've got convection or conduction happening, not radiation. But in any case, there's a link also on that video. Again, it's entitled, "The Sun is Not a Gaseous Plasma, the LMH Liquid Metallic Hydrogen Solar Model." There's a link below that also to the paper, 40 lines of evidence for condensed matter, the sun on trial, liquid metallic hydrogen as a solar building block, the most plausible explanation for what the sun and probably indeed all stars are made from. So it may sound like a crazy and insane idea, but the more you look at it, the more plausible it is. And shout out to Eugene Bagashov, who tends to agree with what I've just said. Perhaps we'll get him on the show soon. So let's continue talking about condensed matter. Turns out that when you put water under hundreds of thousands of atmospheres of pressure, water turns into a lattice structure as well. What happens to water? Well, what happens to water is it turns into a superionized state. The oxygen forms into a lattice structure, and the hydrogen becomes liquid metallic hydrogen, which flows around like a metal. Why are we talking about it? Well, because the structure of the internals of the Earth count as cosmology. As if the Earth is not made at all from what the mainstream believes the Earth is made of, it causes all of the physical sciences to be written, at least rewritten, that is, at least things like geology, as geologic models of what the Earth is made of and how the Earth system works are all based on gravitational accretion models. And without getting all in depth into how solar systems form, what if Earth's magnetic field and also other properties that we see inside the planet are because there's superionized material down there? So it turns out when you get to about 1700 degrees Celsius and 800,000 times the normal atmospheric pressure, you may have things that are nothing like what is expected in the core of the planet. Do you believe that the Earth's core is made of iron? Or is it made of perhaps something else? Do we have everything backwards in terms of the way things form? Do the heavy elements simply form on the surface of stars? Or do we require supernovae in order to create Generation 2 solar systems? And are Earth's magnetic fields generated by superionic materials inside? Now, this does explain lots of things, and a condensed matter star does explain things like the solid body rotation of the sun, as the theory for what is inside of the liquid metallic hydrogen layers of the sun would be solid metallic hydrogen layers. Now, that's never been created in a laboratory, but the phase diagram of hydrogen does include solid metallic hydrogen. And I don't want to go any more in depth into that. We don't want the daily space weather video to be too long. This is another phys.org article featured here on the Smash News Network, least busted name in news, in the Earth section. Go have a read. Earth's deep mantle may have proton rivers made of superionic phases. And again, when you have superionic water, what happens is, number one, the oxygen forms into this nucleonic lattice structure, as you see here. And the liquid metallic hydrogen just flows around inside of that super high pressure area. And also, when an electric field is applied, positive hydrogen ions migrate toward the anode and away from the cathode. So, yeah, that might be a little bit groundbreaking there. And let's continue on with the cosmology segment with a report on cosmic rays. So we've got some cosmic ray monitors to show you here. Here's the Apatity neutron monitor, which has leveled off, although we see a significant uptick here at Apatity over the past 30 days. There's the chart of that. The Barentsburg neutron monitor does not agree. It's flat over the past 30 days. Let's go farther south to Athens, Greece. Here's the Athens neutron monitor. And it's a pretty flat graph there at Athens over the past 30 days as well. How about even farther south to Mexico City? And there's the Mexico City Cosmic Ray Observatory. This one is a 30-day chart as well. You can see it's quite flat over the past 30 days. Let's go back north to Oulu, Finland. And there's Oulu. Small uptick there at Oulu over the past 30 days. And let's go as far south as you can get, Antarctica. Here's DOMB. Small upward trend over the past 30 days at DOMB Antarctica. And here's DOMC Antarctica. Pretty flat over the past 30 days there. And that's today's cosmology segment. We don't want it to be too long, as it is butted in to the daily space weather video. So if you enjoy the cosmology segments, make sure you press like and subscribe, by the way, and press share, as the algorithms hate us, and we need your assistance to get the content onto people's screens. Next, going back to space data, we're moving into the realm of electrons now, and here's the one-year chart of the relativistic electrons that surround planet Earth. And these are measured at the ionosphere layer, the F ionosphere layer, by the GOES 16. Here's a 3-day chart of that. And we got briefly into warning levels the past 2 days. Will we get back into warning levels today? Well, I have no forecast, but here is a forecast. That would be the green boxes. And the NOAA forecast is for a downtick in relativistic electrons. I have no argument or forecast for you there. The yellow diamonds are the observation. Here's a visualization of the total electron content. And I'm seeing this for the first time. If you see me say, oh my God, it's because there's anomalies. And there really aren't significant anomalies. A little bit over the South Polar region, but nothing too exciting there on the total electron content forecast. Here's the F ionosphere layer. This is a diagram of the whole atmosphere. It shows you where the F layer is. And here's where I'm not on screen. It also shows you layers like the troposphere and the penetration of electromagnetic radiation to your ground station. And next we're going to look at the ionosphere here. And this data is courtesy of the Australian Government Bureau of Meteorology. Keep in mind, folks, the resolution of this map is only 1 megahertz. It's not going to show you pre-earthquake signals if you're worried about tiny, tiny striations of 0.01 to 0.02 megahertz. It's not going to show you that at all. Again, each one of these blobs only represents a 1 megahertz difference in vibrational frequency in the ionosphere. This would show any major anomalies happening, however. Leave us a comment if you see something I don't. I don't see any major anomalies here. That's not looking all that crazy. Pretty normal there. Last image from 10:15 Universal Time. Let's talk about climate. The Beaufort Gyre. So the Beaufort Gyre is one of two major Arctic currents. One of them is sort of an extension of the Gulf Stream, which is this transpolar drift, and the other one is the Beaufort Gyre. Well, the good news is the fresh water has been appearing in the Beaufort Gyre, not in the northern Gulf Stream area. So while the Thames froze this year, and that is a major canary in the coal mine for global cooling, and we're going to get deep into the weeds on this, we see a bunch of fresh water making it into the Beaufort Gyre, not into the transpolar drift, an indication that perhaps we're not going to see a year without a summer this year. If you want to read more about the Beaufort Gyre, there's a Wikipedia article about it. Let's talk about the warming of the oceans. So people are very worried about climate change and how Antarctica is melting. I'm just going to let this article scroll here. This is another phys.org article in the Earth section. And I just want to bring up an important fact here that some people don't seem to understand. 1, the Earth is in an ice age and has been for 30 million years, 33 million years or so, when the Antarctican ice sheets formed. The Antarctican ice sheets formed about 33 million years ago when the Earth was 3 degrees Celsius warmer than it is today. Let me just repeat that. The Antarctican ice sheets formed about 33 million years ago when the planet was 3 degrees Celsius warmer than today. So if you think Antarctica is going to melt, there's that little piece of data there to refute what you've said. Very unlikely that Antarctica is melting in any major way. But in any case, here's an article about it. Antarctica Peninsula heating up due to heat in the Tasman Sea. So, without getting any deeper into climate here, the Earth's climate isn't really measurable with the atmosphere, although if we actually knew the temperatures deep in the oceans, we would have a better clue. So let's talk about Monk's Enigma. What's Monk's Enigma, you ask? Monk's Enigma is a large discrepancy between the observed rate of sea level rise and its expected effects on Earth's rotation. So we've seen a lot of YouTube channels saying a lot of things that they appear to not understand. The Earth's rotation has sped up. In the year 2020, the Earth rotated faster than it had in over 50 years. And there are some various different explanations of that. One of the most plausible explanations is global cooling. So there is an equatorial bulge. The larger the equatorial bulge is on the planet, the slower the planet rotates. If the planet's speeding up, one of the plausible explanations for the speed up of the rotation would be a shrinkage of the equatorial bulge. Now, hot ocean water is actually more voluminous. It takes up more space than cold ocean water. And also, if you're depositing more water at the poles because of record snowfall for 4 winters in a row, you're reducing the amount of water in the ocean. So A reduction in the amount of water in the ocean as well as a reduction in the ocean temperature is going to cause the Earth's rotation to speed up. The same way a ballerina or a figure skater speeds up while spinning and she pulls her arms in, she speeds up. Well, so does the Earth. And you may want to read about Walter Munk. Now, Walter Munk is sort of one of my climate mentors. I started studying the climate in about 1987. By the way, press like and subscribe if you enjoy the content. I started studying climate in about 1987 when I first took, well, it was an eighth grade earth science class. And so anyway, now Walter Munk unfortunately passed away on February 8th, 2019, but perhaps read this article as he's got interesting insight as he was using all kinds of data such as the data on historic eclipses to calculate the rotation speed of the planet. So Walter Munk and Munk's enigma fly in the face of a warming planet because a faster rotating planet is not likely to be a warming planet. And I figured some of our YouTube, should I say colleagues? Should I say competitors? I don't know. Some of our fellow YouTube content creators I thought would have probably cited these facts, but maybe it's because they're not aware of them. I don't know. And I'm not going to talk about the flow of continents toward the pole or anything like that, just about the fact that if the oceans shrink or if the oceans cool down because there's less water or because there's less volume because of colder temperatures, the Earth's rotation speeds up as a result of that. Continuing on with more climate stuff, well, here's some meteorology stuff. It's the jet stream scenario of the Western world. So there are the jet streams of the Western world, and they're quite chaotic over the South Pacific, as you can see this S-shaped bend. Here are the jet streams of the Eastern world, and if you're wondering why we show which tabs we show, it's because we've spent a long, long time, years in fact, showing the data sets that we want to show in the daily space weather. And there are the surface winds, and we do see a strong clockwise rotating cyclonic system there in the southern Indian Ocean. This is coincided with a clockwise jet stream scale rotation, as you can see right there. Not an indication that it will increase in strength, and I'm not going to go further in depth into that. I'm just going to continue on with more meteorological data right after I check the life of the stream and get my face off the screen. Here's the pressure situation right now as reported by windy.com. Here's the GFS forecast for tomorrow. There's where we expect pressure cells to be at 12 noon tomorrow. I have no comment. And thanks to that viewer yesterday who asked me what I thought of blitzortung.org. Well, blitzortung.org is actually lightningmaps.org. The one is powered by the other one. They're just different views of the same data. So they've got some technical difficulties there on lightningmaps.org, but blitzortung.org is actually working. So if you ever see lightningmaps.org go down, check out all the lightning over Australia. Yowzers. We've got some terrestrial strikes in the U.S. as well, it looks like. So blitzortung.org is the site that runs lightningmaps.org, which is down right now. So there's the real-time lightning map. And thanks again to that viewer. Next, looking at the lower 48. And I would note, check out all the anomalous low clouds here over the North Atlantic once again, especially these ones up here, as well as a whole bunch around Bermuda, some low clouds over the Gulf of Mexico as well. Here's a water vapor map to give you a little bit more insight. We still see this dry mass of air just stabbing its way into Mexico and Nebraska and Kansas right now. This dry air just stabbing its way in. And if you're a new viewer, you may not be aware that dry air is actually more massive than moist air. And Florida likely has some clear skies. Shout out to our Floridian viewers. Here's a U.S. Doppler radar map. And if you know nothing about meteorology, know this. Doppler radar maps are ground-based radar systems that are measuring vertical movement in the air column. This is a satellite image of water vapor. And if this isn't showing you what you want to see, just go to this. It's the NASA GOES Interactive Weather Satellite. And we're going to actually zoom in on an area here. The Wyoming, Nebraska, South Dakota three-way border. So let's just go to that area real quick. And just bear with me. Again, we are streaming live when we made the video, folks. So here's an area that we see some heavy snow, actually. Heavy, wet snow likely falling there. And I figured I would zoom in here to give anybody in that area, although there probably aren't that many people there, some insight into what's going on. And that dry mass of air is to the south of this area, which could extend the period that moisture stays there, especially if we start to get a counterclockwise rotation of this, but it doesn't look like we're getting any now. So anyway, once again, there's the Doppler radar. Some pretty heavy storms there over most of Iowa. Next, I'd like to thank our patrons, the true source of funding for the content. Please consider becoming a patron at patreon.com/smAshomash. It greatly increases the probability that these videos will continue to not only exist, but remain free, timely, and publicly visible. Patreon.com/smAshomash. Thanks again to our patrons, and what did you think of those animations we made last night? We made some pretty intense and ultra high resolution animations last night of the sun for our patrons. Let us know what you thought. And don't forget to post your comments, folks, as we've got a very important guest. Hopefully will appear soon on the channel. And our patrons know who it is. Nobody else really does. And again, patrons, if you've got questions for that guest, time's running out, as they will be submitted on Friday. So get them to me ASAP. So here are the bonus features in the video. It's a close-up intensity gram of Sunspot 2808, which remains alpha class. Likelihood of major coronal mass ejections low. Likelihood of major solar flares kind of low as well. As we don't see any opposite polarity umbrae there, all we see is this North Pole umbra shown there in blue. Great view of that. And we've got some additional close-ups here. Here's the latest of the sunspot groups. That's part of the Integrated Space Weather Analysis Center. And if you want to look that up yourself, that's on page 1. That's just sunspot groups and magnetogram. So here are some close-ups. Here's the setting of 2806. And let me just make sure that I'm showing the right stuff here, folks. There we go. And there you go. So say goodbye to Sunspot 2806 and hello to Sunspot 2808. That active region in the top, that's former Sunspot region 2807, which has since decayed to plage. Here's 171 angstroms of the same area, and we'll also show you 193, like we just did, but of the new Sunspot 2808. So here's 2808 and 193 angstroms. And that is the last 24 hours. We should see a solar flare there, that C-class flare right at the beginning. And that happened right at 12:30 Universal Time yesterday, if you want to go take your own imagery of that. And last but not least, here's 171 angstroms. Thanks for tuning in, folks. Remember, stare at the sun. Attempt to understand the physics. Don't drink, but if you do, don't drive. Welcome to the Neo-Renaissance. And since it'll never be now again, may that solar wind be at your back.